Hello students, in this session we are going to solve this problem. So this is the given problem. For non-negative integers n, let f of n is equal to sigma k is equal to 0 to n sine of k plus 1 by n plus 2 into pi sine of k plus 2 into 2 by n plus 2 into pi whole divided by sigma k is equal to 0 to n sine square of k plus 1 by n plus 2 into pi. Assuming cos inverse x takes values in 0 to pi, which of the following options is or are correct? So the given options are, option A is if alpha is equal to tan of cos inverse f of 6, then alpha square plus 2 alpha minus 1 equals to 0. Option B is f of 4 is equal to root 3 by 2. Option C is sine of 7 cos inverse f of 5 is equal to 0. And option D is limit n tends to infinity f of n is equal to 1 by 2. So this problem looks complicated, right? But believe me students, the problems look complicated will have simple solutions. So I hope this problem also will have simple solution. So in order to see the solution of this problem, first we need to simplify the given expression, right? In order to simplify this expression, we are going to use trigonometric identities. So how does it look like? When you look at the numerator, so doesn't it look like in the form cos c minus cos d? So we know that cos c minus cos d is nothing but sin c plus d by 2 sin d minus c by 2. And in the denominator, this sin square theta can be written as 1 minus cos 2 theta, which is equal to 2 sin square theta, right? And in the whole expression, let's take, you can observe this pi by n plus 2 is common in all the terms, and this pi by n plus 2 is a constant. It is not variable in the summation. So let's say that let pi by n plus 2 is equal to theta. So when I say that pi by n plus 2 is equal to theta, it can be written as pi is equal to n plus 2 into theta, and further it can be written as n theta is equal to pi minus 2 theta. Just remember this. We may have to use this, right? So now let's try to simplify this. So in order to simplify, let's now take this numerator, that is let's multiply this numerator by 2 and denominator by 2 so that it will be converted into this form, and then we convert the numerator in the form cos c minus d and denominator into the form 1 minus cos 2 theta. So let's do that. So for that, let's multiply this numerator by 2 and denominator by 2, and let's rewrite this equation by taking pi by n plus 2 is equal to cos theta, that is k is equal to 0 to n sine k plus 1 into theta and sine k plus 2 into theta, right? Whole divided by this 2 into sigma k is equal to 0 to n sine square k plus 1 into theta, right? So now we have this in the form sin c plus d by 2 into d minus c by 2. So now let's convert this into cos c minus cos d form, that is sigma k is equal to 0 to n, and we can write this cos theta minus cos, what do you have? 3 plus 2k into theta whole divided by, so we have whole divided by sigma k is equal to 0 to n 1 minus cos into 2 into k plus 1 into theta. Right? So here this cos theta is constant in the numerator. The cos theta is constant and we have n plus 1 terms. We have n plus 1 terms. So that n plus 1 into cos theta minus sigma k is equal to 0 to n cos 2k plus 3 into theta divided by. So this 1 is constant in the denominator. So we can take this out of the summation, that is n plus 1 minus sigma k is equal to 0 to n cos 2 into k plus 1 into theta. Right? Now, if we simplify this summation in the numerator and this summation in the denominator, we'll have the simplified f of n. Right? So let's try to simplify this. So in order to simplify this, let's write here. Let me take the numerator summation, that is k is equal to 0 to n cos 2k plus 3 into theta. So on expanding this, we will have cos 3 theta plus cos 5 theta plus cos 7 theta and so on up to n plus 1 terms, that is cos 2n plus 3 into theta. So how does it look like? Doesn't it look like we have cos a plus cos a plus d plus cos a plus 2d and so on? Isn't it that? Yes, it is. So we know that the sum of the cosines when the angle progresses arithmetically, right? So this sum of the equation, the sum of the cosines is equal to sin nd by 2, right, cos a plus n minus 1 into d by 2, right? So the sum of the terms when you have the cosine series while the angle progressing arithmetically, so we know that the sum of this is equal to sin nd by 2 cos a plus n minus 1 into d by 2 by sin d by 2. So what is our a here? A is 3 theta. Just by comparing this cos a and cos 3 theta, our a is 3 theta and d is 2 theta. So here a is 3 theta, d is 2 theta and n is n plus 1. We have n plus 1 terms in this. So we can write sigma k equal 0 to n 2k plus 3 into theta can be written as sin n, we write it as n plus 1 into d, we write it as 2 theta by 2 into cos a is 3 theta plus n minus 1, n plus 1 minus 1 into 2 theta by 2 and whole divided by sin of d by 2, that is 2 theta by 2, right? So now let's simplify this. So we have sigma k is equal to 0 to n 2k plus 3 into theta is equal to, we have sin n theta plus n theta plus theta, and we have here cos 3 theta plus, so n into theta, that is n theta, and the whole divided by cos sin d by 2, that is sin 2 theta by 2 is sin theta, right? So now we know that, right? What is n theta? N theta can be written as sin 2 pi. What we have? N theta is pi minus 2 theta. N theta is pi minus 2 theta and plus theta into. So let's replace here also n theta with pi minus 2 theta and the whole divided by sin theta. So this is nothing but sin pi minus theta, right? Sin pi minus theta is nothing but sin theta. That means this get cancelled. And here we have cos pi plus theta. Cos pi plus theta is nothing but minus cos theta. That means the summation in the numerator is equal to minus cos theta. Similarly, on expanding the denominator, what do we have in the denominator? We have k is equal to 0 to n cos cos 2k plus 2 into theta, right? We have cos 2k plus 2 into theta. On expanding this, you will have cos 2 theta plus cos 4 theta plus cos 6 theta and so on until we have n plus 1 term, that is cos 2n plus 2 into theta, right? So it is also similar to the summation, that is the sum of all these terms is equal to, it can be written as sin into n plus 1 into 2 theta by 2 into, and cos a is 2 theta plus n into theta divided by, so we have sin 2 theta by 2, or it can be written as sin theta. So we have seen just now, it is similar to this, right? Sin n plus 1 into theta, right? 1 into 2 theta by 2. So this get cancelled. And 2 theta plus n theta. 2 theta plus n theta is nothing but, what is that? Pi. So we have cos pi. So which is equal to cos pi. Cos pi is nothing but minus 1. That is, the summation in the denominator is equal to minus 1. Now let's substitute these two values in this equation. N plus 1 into cos theta minus cos theta. Therefore, our f of n is equal to n plus 1 into cos theta minus of minus cos theta by n plus 1 minus of minus 1, which is equal to, this is n plus 2 into cos theta by n plus 2. Oh, n plus 2 get cancelled and is equal to cos theta. That means the given function f of n is equal to cos theta. That's it, isn't it? So the given function is f of n is equal to cos theta. So now it is more easy, right? So on simplifying the given function, we came to know that f of n is nothing but cos theta. So if f of n is equal to cos theta, then we can easily cross-check the options, right? So we know that theta is nothing but, so this f of n is equal to cos theta. Theta is nothing but pi by n plus 2. That means our f of n is cos of pi by n plus 2. Now let's take the first option. What is the first option? A. Alpha is equal to tan of cos inverse of f of 6. Then alpha square plus 2 alpha minus 1 equal to 0. Let's see what is alpha here. Alpha is tan of cos inverse of f of 6. F of 6 is nothing but cos of pi by 6 plus 2. Right? So on taking this, you will have cos tan of pi by 8. Tan pi by 8 is nothing but root 2 minus 1. So what to check? Alpha square plus 2 alpha minus 1. So alpha square plus 2 alpha minus 1 can be written as? So it can be written as alpha plus 1 whole square minus 2. So this is root 2 minus 1 plus 1 whole square minus 2, which is equal to 0. Whoa, then it's correct. Right? Our option A is correct. Let's check the option B. F of 4. F of 4 is nothing but cos of pi by 4 plus 2, which is equal to cos of pi by 6, which is equal to root 3 by 2. Wow, this is also correct. So option B is also correct. Now coming to the option C. So what do you have in the option C? Sine 7 cos inverse f of 5. That is nothing but 5 plus 2. So we have here sine pi, which is equal to 0. Wow, this option C is also correct. It seems all the options are correct. But let's check the D as well. Limit n tends to infinity, f of n is equal to 1 by 2. When n tends to infinity, cos pi by n plus 2. What do you have? So it tends to cos 0, right? So cos 0 tends to 1. That means when limit n tends to infinity, it tends to 1 but not 1 by 2. So that D is not the correct option. So among the 4 options, 3 options are correct. A, B, C. Right? That's it. Isn't it simple? I told you right in the beginning of the explanation, when the problem looks complicated, it is easy to solve it. So I hope it answered your question. Right, students?